Thank you for the introduction, Leon. Hello, everyone. I'm Tian. Today, I'm going to present you our recent progress on ultra-compact, high-performance metasurface flat optics. Wide-angle optical systems are always desired for high-performance imaging, sensing, display, and many other applications. In contrast to human eyes that can give us a field of view up to about 200 degrees with two eyes, conventional camera lenses require much more complicated multi-lens assemblies. Take fisheye lens, for example. Usually, at least 7 to 10 lenses are stacked together to correct for the angle-dependent aberrations. As a result, the design complexity, bulkiness, and incurred high costs have limited the practical deployment of wide-angle optical systems. This performance gap is further exaggerated in the rapid growing markets involving human-machine interactions, such as 3D optical sensors, augmented or virtual reality devices, and so on. As an example, 3D optical sensors nowadays rely on conventional lens assemblies and usually have limited field of view less than 90 degrees. On the other hand, mini fisheye lenses compromises on the imaging qualities and usually use bulkier structures. Our customer interviews have indicated that compact, wide field of view 3D sensors are indeed highly demanded. Our team pioneered a novel metasurface flat optic technology, which is capable of high-resolution imaging over a record hemispherical field of view. Metasurfaces are optically thin, sub-wavelength arrayed nanostructures that are engineered to provide almost arbitrary control of propagation of light, while maintaining high optical efficiency. Our wide field of view metalens consists of a single flat transparent substrate with an input aperture on the front surface and the metasurface on the back surface. Light beams incident on the input aperture at different incident angles are refracted to the backside metasurface and continuously focused onto a planar focal plane. We have demonstrated that our metalens design can achieve diffraction-limited imaging performance over a record 180-degree field of view. The design can be used in both ways for light detection and emission. This means that we can obtain high-resolution, aberration-free imaging or image projection, not only near the center, but also at the edge of a panoramic scene. Furthermore, our design architecture is generic and can be adapted to different spectral range of light. The metasurface fabrication is compatible with the standard CMOS processes, so that we can leverage semiconductor foundries to scale the manufacturing at low cost. Leveraging this novel metalens technology, we are developing advanced 3D sensing solutions with dramatically improved performance, as well as the size, weight, power, and cost advantages. Here, we utilize the same metalens architecture for illumination and camera optics, which is universally applicable to all major methods of imaging-based 3D sensor. Compared to state-of-the-art, our metalens-based 3D sensor features a 2x extended field of view, 10x higher resolution, enhanced signal-to-noise ratio, and also an ultra-compact form factor with a minimum element count. When integrated with AR or VR modules, the embedded 3D sensor will provide an immersive 180-degree field of view and an angular resolution matching the human eye. We envision that our compact 3D sensor will find wide applications in consumer electronics, automotives, industrial automation, and so on. In addition to 3D sensing, our flat optic approach will also transform a variety of critical optical technologies that still rely on traditional optical systems today. Our unique optical architecture and engineering capabilities allow highly versatile development of technologies to meet diverse needs in consumer, defense, and medical sectors. Lastly, I would like to introduce our core team members here. Our team uniquely consists of material scientists, applied physicists, and optical engineers from MIT. We have in-depth experience in design, fabrication, and prototyping of metasurface flat optics. We work together not only to tackle the most challenging problems, but also develop a platform to allow people to reimagine what they can do with optics. We think this is the right time to transition the technologies to market and look forward to developing synergies within the community. With that, I will conclude my talk. I welcome you to stop by during the breakout session and reach out to me offline. Thank you.